Hello, exercise 17C.2. I'm going to try and squeeze the remaining questions from the last PowerPoint and the new PowerPoint all together, so we can still do this in two PowerPoints. So this is 17C.2, slightly adapted from what I originally intended to do. But you'll notice we're basically looking today at using the Classwiz to solve binomial distribution problems. Last time we did a question, or a number of questions, using the binomial distribution using the formula. And here's one such starter for us, just to remind us of it. You should remember that we get this using the NCR button on the calculator. Let's just look at it. Sometimes they do exactly this. They say x is binomial. So this is telling me that it is binomial, and it says that n equals 6. The first number is always the n. The second number is always the p. Okay. Find the probability that x is less than or equal to 1. So I'm doing something 6 times, and it's saying what's the probability of getting less than or equal to 1 times being successful. Now just think about what that means. I'm doing something 6 times, so I'll either get no successes, 1 successes, 2 successes, 3, 4, 5 or 6. I might get all 6 right. I don't know what it is, perhaps I'm spinning a spinner or something. But I might get, just by pure fluke, all 6 of them, or 4 of them, or 5 of them. Now the question says, what's the probability of I get less than or equal to 1 of them? So in actual fact, I want these two to come up. So I'm just going to write this. I need to either get probability x equals 0, or I need to get the probability x equals 1. They are the two possible outcomes which would make me think, I've got less than or equal to 1 successes when I roll it 6 times. So let's just do the formula. The formula says you do NCR button. In this case, it's because n is 6, I do 6C0, and I times that by the probability of 0.4 to the power of the number of times I want to be successful, and here it's 0. And then I do the other probability, and again 1 minus p in this case has got to be 1 minus 0.4, which is 0.6. So it times by 0.6, and again I do this to the power. Now these two numbers always add up to n. That's the rule, effectively. So if this is 0, this has got to be 6. I'm unsuccessful so many times. I'm never ever successful. In fact, I get 0, but I'm unsuccessful 6 times. And I'm just going to type it into my calculator. So 6C1 I know is always equal to 1. Anything 6C0, sorry, 6C0 times by 0.4 to the power of 0 times by 0.6 to the power of 6. According to my calculator, it's a rather, I'm going to do it to 4 dp or something like that. 4, 6, 6. In fact, I'll write it all down. 6, 6, 5, 6 I get. And the probability of being successful once is 6C1 times by 0.4 to the 1 times by 0.6 to this time it's 5. Notice these add up to 6. So I'll do it again. So it's 6C1 times 0.4 to the 1 times 0.6 to the 5, and this is 0.186624. Now to get the probability therefore that it's less than or equal to 1, I've got to write it like that, less than or equal to 1, and it's those two probabilities I've just calculated added together. So plus 0.186624, let's just do that on my calculator, plus 0.04 6656 plus the other one equals, I get 0.2, and this time I'm going to round it to 3 significant figures, 233. Haven't got quite a lot of answers. Good, that's the answer. Now notice though, that was quite a lot of work, and we don't really want to have to do quite a lot of work. And the good news is that there is a calculator button on our calculator on the Classwiz, and this is why we buy this posh calculator, because it does it for us. So notice there's two options when we do it. There's binomial PD, for example, is when we want an exact probability, but there's a binomial CD, which actually stands for cumulative distribution, which gives us less than or equals. Notice the way I do it. I press menu 7, 4, 2, or menu 7. I then have to press down 1, 2. So it's a bit of work, but it's damn sight easier than having to do it yourself. So let's have a question, and it says, given that x is binomial 7, 1/4. Well, presumably I'm trying to land on red. I can't write I'm trying to land on red, and the probability of landing on red is 1/4. That seems reasonable. I want to know what's the chance if I do it 7 times of I get exactly 2 reds. And I can just do this on my calculator. I'm going to talk you through the keys I'm going to press. See if you can do it now. First of all, we have to press, because it's an equals one, I have to press binomial PD, because they're the equal ones. So we go menu, and you press 7, because that's the one with a pretty distribution graph on it. And we have to then press, it says 4, and you'll notice I then press 2. I always choose the variable option. Now, once I've got to this stage, it says, what's your x value? Well, you can see my x value here is 2. So I'm going to type in 2. What's your n value? Well, that's 7. And what's your p value? Well, that's a quarter. Just type in 1 over 4, 1 divided by 4. And it comes at 0.25. Now, when I press equals again, I've got my probability. It says 0.311. And I don't need to show any working out. I just need to get my right answer. Let's do this one. Oh, be slightly careful of this. It says the probability, still x is binomial of 7.25, but now it's the probability x is less than 4. So the reason why I'm saying that is less than 4 is actually the equivalent of less than or equal to 3. So I'm doing this 7 times. These are the possible outcomes I could get, not all the way up to 7, where I'm successful. That's the number of reds I could get. Now, less than 4, these are the numbers less than 4. Now when I do this, because it's a less than or equal to 1, I have to use my binomial CD button. So this time menu 7, and I press the down button. And it says binomial CD at the top, so I press number 1. And then I always pick variable, so variable. So what's my x value now? Notice it's not 4, because this button requires it to be less than or equal to. So now I'm going to type in 3. My n was 7. My p was 0.25, I pressed equals, this time I've got 0.929. This one here, we've got to be a bit careful, look at that, it's a greater than or equal to. So again, I want greater than or equal to 2. So again, I'm listing out all my numbers. 5, 6, 7. I want 2 or more. Now, there isn't a button for that. There just isn't a button on the calculator for that. But luckily, we can cheat. We can say this is the opposite of, and because it's the opposite, it's 1 minus the probability of getting 1 or less. So I go x is less than or equal to 1. And just by working out what I want, I know what I don't want. So I'm going to write 1 minus, and I'm going to do this calculation based on this 1 figure. So what we've got, my value I'm typing in is, and again, notice I want binomial CD. Now, it's CD because it's a less than or equal to 1. Less than or equal to 1 that I'm calculating the probability of. Luckily, I'm on that already. So x is 1, n is 7, p is 0.25, press equals, it's 0.4449. Now notice that's not the answer because I've got to do 1 minus it. So I now have to go menu 1 to get back to my calculator mode, 1 minus 0.4449. And that's come up with 0.555 to 3dp. 3 6 figs, whatever. So we've got the answer. There they are. Interestingly, I wrote that one as 0.5551. So here's another question. It says x is binomial 13,0.72. I think it's exactly the same, it's just different numbers. So the very first thing, notice the first question says, do you give me an exact probability, an equal sign? We're going to use binomial PD. So menu 7, 4, 2. What are we going to type in? Well, my x value, it says is 4, so type in 4. My n value, well, in the question it says n is 13. What's my p-value? Well, my p-value, it says in the question, is 0.72, so type that in. And when I press equals again, it should give me my probability. Oh, I've got a rather nasty probability on my calculator. Now, you might have the same as me in terms of my number came up in standard form. So I'm going to force my number out of standard form. If you don't know how to do that, you might want to come and see me in class and I'll show you how to do it. But or you can just convert it yourself. I get 0.00203. I wouldn't be surprised if you got 2.03 times 10 to the minus something or other, 10 to the minus 3. Next question, probability x is greater than 11. Again, think what 11 this means. It means I want 11, I want 12, I want 13. It only goes up to 13, so they're the ones I want. But of course it means I don't want 10, I don't want 9, I don't want any of these numbers down to 0. So the opposite of 11 or more is that lot. So I think this is 1 minus the probability that x is less than or equal to 10. And notice how that number sometimes has to change. And notice it's a less than or equal to, so this time I'm going to do the binomial CD. So menu 7, press the down button, press 1, then pick variable. And what do I want? N now is 13, still 0.72, but the number I'm typing in is 10 for x. I'll press equals once you've done that. And remember, this is 1 minus 0.7505. It's got to be 1 minus, it says right there. So I'm going to go menu 1 to get back into calculator mode. 1 minus 0.7505. On my calculator it says 0.2495. I could round that obviously to 250 if I want. Probability of greater than 7 again. Just in your head, get your head round. 6, 7, 8, 9, up to 13. So I'm just trying to get a feel for what this greater than 7 is actually 8 or more. Because I don't want it equal. 8, 9, up to 13. So the ones I don't want, because this is a greater than, I have to convert it again. It's 1 minus the probability that x is less than or equal. It's actually equal to 7. So this number doesn't change. This is what I'm trying to get at. Sometimes you've got to change it, sometimes you don't. So let's type those in. It's a binomial CD again. So menu 7. It says press the down 1 and 2. After a while you'll get good at that. You'll know exactly what you're typing in. And we want x is n is 7, x is 7, n is 13, and p is 0.72. And I've got on here it's 1 minus 0.12699. And if you do that, you get 0.87. Round it properly. I reckon it's 3. Let's see what my answer said. Yes, 0.873. So, and the others all work, yes. Here's another example. It's the same idea. Let's go for it straight away. The first one is less than or equal to, so that's binomial CD. So, in fact, why don't you pause the video? It's probably a good idea if you pause the video and see if you can get the right answers. I'll put the answers up in a bit. Look, hopefully you've done that. Hopefully you've paused the video, you've got 3 answers. Here are my answers. See if you get the same as me. I say that, it doesn't work. Ah, there they are. So hopefully you've got those 3 answers. If you haven't, try again. And again, I'm going to do the same here. I want you to do these. So I've got 3 examples for you to do. Press the pause button and see if you can get the answers to these 3 questions. Right, that's me done. I mean, hopefully you've done them. So here's my 3 answers. Did you get the right answers? If you didn't, go back and do them again. Now, we do get some questions which are slightly different. These are, I'm describing as the in-betweeners for obvious reasons. It's when you want to find the probability of 2 values, between 2 values, so like between 2 and 5. So we do it the same way, but just notice the way I've got to do this. For this part A, it says x is binomial 12,0.4. That's okay, we're not fussed by that. But in order to get between 2 and 5, let's just list all the possible outcomes. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I want between 2 and 5, and it can be equal to both. So I want the probability of these coming up. Now, the way I do this, pay attention. If it's between 2 and 5, like this, and it can be equal to them, I do the probability that x is less than or equal to 5. Now, think what that means. It means all these, unfortunately, it includes this 0 and 1. So then I take away the probability that x is less than or equal to 1. And you always do these takeaways with these in-betweeners, but notice it's not necessarily the numbers they give you. I've used 1. So I'm just going to do this on my calculator, and I'll pause it and come back. So I've typed those in. I've got 0.665 for the first one. I typed the second one in. I got this 0.01959. Presumably when I take them away, I get a, there's not much difference, to be honest, in the answer, because the second answer is so small, and I get 0.6456. So look, we'll practice this in class. Well, this is just a first look, and we certainly need some more examples before we can do it, but hopefully that's okay.